Hello everyone, it's Atif Sheikh here and I welcome you all for the sixth session of Railway Engineering. In today's session, we will be discussing about the rails. At the end of this session, you will be able to explain what is mean by rail, its manufacturing process, its chemical composition, different components of the rail and different types of the rails. So let's find out the answer for the simple question, that is what is mean by rail. So the rail is simply one of the member of railway track which provides continuous and level surface for the safe movement of the train. Generally, this rail is made up of a steel having a chemical composition as shown in the figure. As you can see, the important chemical composition of the rail steel are the carbon, manganese, silicon, sulfur and phosphorus. You can learn more in detail about the manufacturing process of rail steel in the above tagged video. Well, in India, there are only two companies which are involved in the manufacturing of the rails. Those are the government-owned Bhilai Steel Plant of Steel Authority of India Limited, and another is the Raigad Steel Plant owned by the private limited company known as the Jindal Steel and Power Limited. Now let's discuss the important functions of the rails. The most important function of the rail is to provide hard, smooth and unyielding surface for the rolling of the rigid tired wheel on it. Another prime function of the rail is to act as a beam and transmit the wheel load safely to the wider area of formation through sleepers and ballast below it. The rails also serve as a lateral guide for the wheel of the train. So we have discussed three main functions of the rail. Now each rail is having a different components like the web, foot and the head. Now each of these components are designed to perform a specific function. So let's discuss these components one by one. Now the first comes the head. It is the topmost portion of the rail which provides the wider running area and the lateral stiffness to the rail. Generally, the depth of this rail head should be kept adequate enough to bear the wearing in service life. Now if you closely observe the shape of the rail head, it is the combination of the curves of three different radii, varying from quite very sharp curve to a very flat curve. And these are designed to fit with the shape of the wheel tire in order to form a combination which will provide a good riding quality and the minimum contact stresses. The second important part of the rail is the web. Web lies in between the head and the foot. Now it is very important to provide a thick and sturdy web of the rail to provide the adequate shear strength to the rail, to protect it from the failure, particularly at the fishbolt holes, even under the impact loading at the joints. Third and the bottommost part of the rail is known as foot. The foot should be wide enough in order to provide stability against overturning as well as to distribute the upcoming load over the larger area of the sleeper. Now here one should understand that the moment of inertia of the rail section is the true index of its stiffness. For rail section, both horizontal and lateral stiffness are important. Vertical stiffness helps the rail to transmit the load safely to the sleepers underneath, while the lateral stiffness enables the rail to withstand the lateral forces it is subjected to under the moving traffic load. So the design of rail section should be such that it should provide maximum moment of inertia with efficient and economical section. Now let's jump to the different types of the rails. The first rail used were the double-headed and made up of eye, or you can say dumbbell section as shown in the figure. The idea behind providing two head was that once the head wore out during the service, the rail can be inverted and reused. However, it was found that the old foot had also worn out at the slipper support and it did not produce a good running quality after it was inverted to become a new head. So this led to the development of the bull-headed rail, also called it as a BH rail. Bull-headed rail had almost similar shape but with the more metal in the head in order to withstand the wear and tear. But this rail section had a major drawback that the chairs required for fixing with the slippers. So the next version of the rail invented was the flat-footed rail. It was introduced 70 years ago. The performance of the flat-footed rails on the track found to be superior to the other two types for the same weight. Flat-footed rails have more lateral strength, the number of fastenings required are few, and their tendency to get loose is less. So presently, these rails are being used all over the world. Now the evolution of the rail section can be linked to its normal weight per unit length. In the early days, the axle loads were small and the rails were light. As the traffic density increases, the axle loads were increased, so the heavier rails were introduced. The heavier rails are also being introduced on high-speed routes, as it has been found that the track geometry can be well maintained with them. So remember one thing, that these rail sections are designated by its weight per unit length. For example, in FPS system, rails are designated as pounds per yard, while in metric units it is designated as kilogram per meter. On Indian Railways, a flat-footed rails of 52 kg and 60 kg are being used predominantly. So I hope you understand that the 52 kg rail indicate it has a weight of 52 kg per meter. Now the weight as well as the section of the rail can be decided with the help of the important criteria like the maximum permissible speed, the heaviest axle load, the depth of the ballast cushion, as well as the type and the spacing of the sleepers. So these are the rail sections which has been standardized on the Indian Railways for broad gauge, meter gauge and narrow gauge sections. Now as mentioned here, the old 90R section is adequate for the annual traffic density of 10 GMT with the permissible limit of 100 km per hour. This rail section is having a service life of 20 to 25 years. So realizing these limitations, Indian Railway designed heavier section known as 52 kg section in 1959. This section is designed to meet the requirement of heavier and faster traffic. So this rail section was recommended for all the broad gauge main line routes having a future speed of 130 km per hour and having a traffic density of about 20 to 25 GMT. But as the traffic density on the broad gauge track routes of Indian Railway is increasing, so accordingly to meet the future requirement, a new section is designed known as 60 kg section. This section is designed for the future speed of 160 km per hour with the traffic density of about 35 GMT. Even there is a proposal to use 68 kg section for the dedicated freight corridor of Indian Railway. The typical cross section and the key dimensions of all these important rail sections are available in the lesson on Moodle. Now, though the weight of the rail and its section depends upon various considerations, the maximum axle load that a rail can carry can be computed with the help of this simple thumb rule. It indicates the maximum axle load carried by the rail is equal to 560 into the sectional weight of the rail in pounds per yard or in kg per meter. Now we talked a lot about the different types of the rails based on its cross section and its weight. What about the length of the rail? Theoretically, longer is the rail, the lesser would be the joints and fittings required. Longer rails also provides smooth and comfortable rides, as well as it leads to the economical construction as well as maintenance. However, the length of the rail is restricted because of various reasons, like the lack of transport facilities for the long rails, particularly on the coast, difficulties in manufacturing the long rails, then the difficulties in providing a big expansion joint, as well as due to the heavy internal thermal stresses induced in a long rail. Taking these things into consideration, the Indian Railway has standardized a rail length of 13 meter for the broad gauge track and a rail length of 12 meter for the narrow gauge and meter gauge track. Indian Railway is also planning to use the longer rail sections in its track. JSPL has already announced that they have manufactured the India's longest rail length of 121 meter at their Raigad steel plant. Now, the service life of the rail is also depends upon the ultimate tensile strength of the rail, denoted by the UTS. Now, Indian Railway has mostly been using the medium manganese rails having the ultimate tensile strength of 72 kg per mm square. Let's consider a 52 kg section with 72 UTS. Such a section is having a service life of only 350 GMT. So on a track having the annual traffic density of 20 GMT, the renewable cycle of the such rails would be only 17 to 18 years, which is quite short as compared to the life of concrete sleepers, which is 50 years. Moreover, such rails veers fast at curves and the gradient sections. The total GMT that a 72 UTS rail can carry is as shown in this table. So in view of all above considerations, Indian Railway has been importing a 52 kg rail section with 90 UTS for some time. These rails are having many advantages. For example, the service life of the 90 UTS rail is about 50% more than that of the conventional 72 UTS rail. 90 UTS rails are more resilient against the wear and are having the more hardness value. Also, the allowable shear strength value for 90 UTS rail is much higher. Above all this, Indian Railway in 1990 has imported about 45,000 tons of 110 UTS rails. These rails are laid on the busiest corridors like the Mumbai division of the Central Railway. So far, these 110 UTS rails has given a better performance and their further behavior is still under watch. So finally, let's summarize this session. In this session, we learned about what is mean by rail, what are the chemical composition of the rail steel, three important types of the rails like bull-headed, double-headed and flat-footed. Then we have also discussed about the different types of rails based on its sectional weight as well as UTS values. So I hope through this session I have clearly explained the things about the rails. Thanks for watching.